Hi everybody, I wanted to do a part 2 on completing the square and look at some more examples of how to do that. So I've got two problems up here. The first one, it's m squared plus 12m equals negative 8. And what I need to do, just like in yesterday's video, is I need to add something to both sides of the equation that makes this polynomial on the left side a perfect square. Today I did something a little different. I drew a picture of a box, one of our factoring boxes that we used to use. And if you remember how we used to factor with these, I would take the first term and the last term and they would go inside this box on these two corners. But that last term is not there. That's the one we want to figure out. What we do know is that the two things to multiply to give us m squared are m and m. So I can fill that in. I'm just going to try to fill in as much of this box as I can. And I'm trying to make this a perfect square. That's why it's called completing the square. And the other thing you might remember is that these two parts of the box, they added together to give us 12m. So you needed two numbers that multiplied to give us this last term, which we still don't have, but add to give us this. Well, if it's a perfect square, these both need to be the same thing. So if they both need to add to 12m, and they both need to be the same, there's only one answer that it could be. This has to be 6m, and this has to be 6m. Which means this is m plus 6 and m plus 6. Now, in order to make all of this work out and be true, we need to have this last part here be the product of 6 and 6. So I need to do 6 times 6. That gives me 36. And that's what I'm going to add to both sides of the equation. So yesterday, the way I showed you how to do that was a little algorithm where all you do is you take the 12m and we divide it by 2. So 12 divided by 2 and then square it. Well, that works also. 12 divided by 2 is 6. 6 squared is 36, and that's what we add to both sides. And the reason it all works is because it makes this thing a perfect square. Now that I've got my perfect square, I can rewrite this whole equation. So on the left side, I can write it just like it is, or I could write it as m plus 6 times m plus 6, or m plus 6 squared. And on the right, I need to do negative 8 plus 36, which is going to be 26, positive 26. That's not right. Positive 28. Okay, now, to answer this question, to finish this off, I need to get rid of this squared term. So I need to take the square root. And I'm going to do that on both sides of the equation. When I take the square root, remember there's two answers. It could be the positive, the principal square root, or it could be a negative. So I'm just going to take the square root of 28 on my calculator. I know it's going to be a little bit bigger than 5 because 5 squared is 25. 6 squared is 36, so it should be closer to 5, so maybe 5.2. That's my guess. But let's try it. Square root 28, 5.29. So I get, when I take the square root on the left side, just m plus 6, and on the right hand side, I get 5.29, so approximately equal to 5.29. Could be plus or negative 5.29. Now, what do I do with all that information? I've got two answers. I've either got 6, I've got to subtract 6 from both sides, cancel. And so I've got 5.29 minus 6 or negative 5.29 minus 6. Those are my two answers. So 5.29 minus 6, that's going to be negative 0.71. And then negative 5.29 minus 6 will be negative 11.29. Did all of that fit in the video? Just barely. Okay. So all of that math, I did this part twice, figuring out what to do that. I'm going to do the same problem again, a little bit faster, with different numbers. This one starts a little bit different. See, all the ones we're doing have an m squared or an x squared, nothing in the front, which makes it a little bit easier. This one has something in the front, but we can actually find the greatest common factor of those three terms and factor that out. That's going to be 3. So over here, I'm going to start, just to simplify this, if you can do that, you do that. Divide by 3, divide everything by 3. And you get g squared minus 8g plus 9 equals 0. I want to make this look like that over there. Over here what I had was I had the two terms with the variable on the left side, and then I had a negative 8 on the other side. I'm going to subtract the 9. So I do minus 9, and then I get g squared minus 8g equals negative 9. And I need to figure out what I can add to both sides of this equation to make this a perfect square. Well, you could make this box again and figure it out. Do that really quick. So I'll put a g squared here. We don't know this term here. G. What two numbers add together to give you negative 8g, but they have to be the same number? Well, that's got to be negative 8 divided by 2. So negative 4g, negative 4g. So this is g minus 4 times g minus 4. Negative 4 times negative 4 is positive 16. So that's what I'm going to add to both sides. Plus 16 plus 16. Now I can take this equation on the left and write it as g minus 4 times g minus 4, or g minus 4 squared equals negative 9 plus 16. That's going to be positive 7. Then I have g minus 4 squared equals 7. This one is where I take the square root of both sides. Plus or minus the square root there. And I get g minus 4 equals positive or negative. We'll find out what the two answers are, but let's take the square root of 7 first. Should be less than 3 and bigger than 2. 2.65 about. So approximately equal to 2.65. And then I need to add 4 to both sides. So when I do all of that, I get two possible answers. I get g is equal to 2.65 plus 4, or negative 2.65 plus 4. Those are my two possibilities. 2.65 plus 4 is 6.65. Negative 2.65 plus 4 is going to be 1.35. And then those are my two answers. Okay, so that's just more examples on how to complete the square and solve these equations. The next video, I'll show you a big formula that you can use for these instead of completing the square. But I wanted to show you both because this becomes useful in other situations. And it also explains why the formula, the quadratic formula we will learn, is going to be like why it works. So have a good day, everybody.
Thanks.